Hi, my name is Nurul Faraina binti Mustafa Sharafuddin, metric number AA201123. So I will start with introduction. As we all know, in pressure vessel and gun bearings, the analysis of the stress distribution in a thin wall cylinder is essential. Strain are measured using stress gauge positioned on various radius and at various elements across the cylinder wall. As a result, the stress distribution along the inside wall of a cylinder subjected to internal pressure could be investigated. So next we go to the additional theory. A thin cylinder is cylinder-shaped equipment with a thin wall. The thin cylinder's thickness should be less than 1/10 to 1/20. Because the cylinder has a thin wall, longitudinal stress can be assumed to be constant independent of wall thickness or area. Two different pressure loading situations will be investigated. The open-end condition is similar to evaluate a part of a long pipeline. The closed-end condition, on the other hand, is similar to examine a sealed gas tank containing a specific amount of pressure. There is no axial load on the open-end cylinder. In the open-end cylinder, there will be no direct axial stress. Typically, low pressure applications such as boiler shell, pressure tank, and pipe use the cylinder idea. To withstand high internal pressure, the thin cylinder will be tightly coiled by a wire bond type, a well-known type of pipe. The tension in the wire that ties the cylinder will generate early compressive stress in the pipe before delivering the internal pressure. As a result, when the internal pressure was applied, the cylinder and the wire cooperate to resist the bursting force.
Hello, my name is Nailina Ashikin binti Muzamil, my metric number AA200181, and I will continue the presentation for the objective and the conclusion. So our objective are, we want to determine the two conditions of thin cylinder which are in open and closed end. Second is to determine the Young modulus and the Poisson ratio of a thin cylinder through this experiment.
Hi everyone, so this is your matrix number EE200921. Equipment needed for this thin cylinder experiment is mechanical pressure gauge to show the value of the pressure, cylinder, hand wheel, release valve and also pump to increase the pressure in thin cylinder. In the open end condition, the hand wheel is fully screwed in. In the closed end condition, the hand wheel is worn out. Length of the cylinder is 358.8 mm and the thickness of the wall is 3 mm. Inner diagram 80 mm and the Young modulus is 69 giganewton meter square.
Hi, my name is Ong Kang Nen. Let me explain the procedure of thin cylinder. Firstly, switch on the power to the thin cylinder. Open, turn anti-clockwise the pressure control and screw in the hand wheel to set up the open end condition. At the VDAS, select the open end experiment condition. Shut, turn clockwise the pressure control and use the pressure and hold to zero button to zero the strain gauge display reading. Record the first set of reading at zero pressure into your blank result in table 1. Pump the hand pump until the pressure is approximately 0.5 mega-Newton per meter square. Wait for a few seconds for the reading to stable and record the reading in table 1. Repeat the procedure in 6 by 0.5 mega-Newton per meter square, pressure increment until 3 mega-Newton per meter square. Open, turn clockwise the pressure control to reduce the indicated pressure back to 0 MN per meter square. For the closed end condition, the procedure is almost the same. But step 2 is open, turn anti-clockwise the pressure control and carefully unscrew the handle to set up the closed end condition. At the VDAS, select the closed end experiment condition. And step 5 is changed to pump the hand pump until the pressure is approximately 3.0 MN per meter square. Wait for a few seconds for the reading to stable and record the reading in table 2.
For observation, the outer diameter of the thin cylinder is 86 mm. The thickness of the wall of the thin cylinder is 3 mm. Pressure control started to work when the hand wheel turned in anti-clockwise direction. The screen cost value showed 0 when pressing and holding the button beside the display. And also, when the hand pump is pumped, the pressure value started to rise in the pressure gauge and also in the system. If the pressure increases, the hoop stress will increase. When the pressure increases, the strain value also increases in open end. When the hand wheel is unscrewed, it will change the condition of the thin cylinder from open end to closed end. Pressure control is adjusted to reduce the pressure in the thin cylinder.
Lastly is conclusion. In conclusion, we can conclude that our experiment has accomplished its objectives, which are to determine the open and closed ends of the thin cylinder. It shows that the thin cylinder is cylinder-shaped equipment that has less thickness. From the discussion, we have obtained that Young's modulus and the Poisson ratio of a thin cylinder through the experiment. Both conditions use the cylinder to measure strain. There is no direct axial stress at the open end condition since there is no axial load. If the cylinder has axial loads, there is direct axial stress at the closed end. In open end condition, when the hand pump is pumped, the pressure and the hoop stress will increase, and due to that, the strain value also increases. At pressure 3.0 MN, the hoop stress for both open end and the closed end thin cylinder is the same.